Good evening, guys. My name is Moidin Waliu, so popularly called Dr. Nefon. Now, so today I will be dropping ways of solving or balancing a redox reactions. How do we balance a redox reactions? And what do we call redox reaction? Redox reaction simply means what? Reduction and oxidation. That's the meaning of what? Of redox reaction. It what it means what? It means reduction and oxidation. Now don't forget that reduction and oxidation reaction can be defined in different terms. Number one, reduction can be defined as the removal of oxygen and addition of hydrogen. Also, oxidation can also be defined as the addition of oxygen and removal of hydrogen. In terms of electron, reduction is a gaining of electrons, while oxidation is what is a losing of what? Of electron. In terms of oxidation number, oxidation is the increase in the oxidation number, while reduction is what? Is a decrease in what? In oxidation what? Oxidation number. Hope you are getting that. Now, so how do we balance a reaction, a redox reaction? Very very simple. Now you see there are two things that you have to know in balancing of redox reactions. There is a topic called ionic equation. Ionic equation. There's a topic called what? Ionic equation. Now you see, ionic equation is a type of equation that contains ions. The type of equation that contain ions are called ionic equations. Now, there are now two types of ionic equation. We have the simple ionic equation and we have what? We have the complex ionic equation. These are the two types of equation that we have. We have what? Simple ionic equation and complex ionic equation. And the two, JAM are going to ask, they are going to ask questions from the two. Either simple or what? Or what? Or complex, depending on your luck. You get it now. You might be lucky. You have what? You see your simple ionic equation, and if you are not, you can see what? You can see complex ionic equation. Now, what actually differentiates between the two is that simple ionic equation is a type of equation that do not contain radicals. I said what? What? Radicals. The type of ionic equation that do not contain radicals is called what? Is called simple what? Simple ionic equation. While the type of equation that contain radicals are called complex ionic equation. What's radicals? Radicals are a group of atoms or what? Or elements that possess charge. Do you get it now? Why ions are groups they are not groups of elements. They are single elements or atom that possess charge. Do you get it now? For example now, if I give you Cl minus, this one is called chloride ion. But if I give you SO3 2 minus, this is called sulfite radicals. Sulfite radical, or you call it what? You call it trioxosulfate 4 radicals. Do you get it now? Because group of element, that is sulfur and oxygen, they combine together to form the what? To form the radicals. Do you get it now? And they possess what? They possess charge. Hope you are getting that. So any type of equation that contain a what? A radicals are said to be complex ionic equation. Now, how can we balance a reaction in both simple and what? And complex ionic equation? Now, the first thing is what? The first thing to know is that how can I balance it? For example, we are given what? We are given aluminium ion plus zinc to give us Al plus zinc 2 plus. Now, there is mnemonic that I usually use, ACE. 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 The first thing is what? Indicates the redox reaction. Indicates your oxidation and reduction from that particular equation. Do you get? You first indicate your oxidation and reduction. After that, you will balance them atomically. You balance the atom, number of atoms. After balancing the atoms, you what? You balance the charge. You balance the charge. That's the meaning of C. Then after balancing the charge, you what? You balance the what? The electrons. Are we getting that? Now, so the first thing to do is what? Now I have what? Al3 plus to what? To Al. Also, I have what? I have Sn to what? To Sn 2 what? 2 plus. Now class, do not forget that oxidation number matters very very well. Now in this aspect now, do not forget that the charge carried by element is equal to their oxidation number. So what is the charge of aluminum here is +3. That means the oxidation number of aluminum here is what? Is +3. Here is what? Is 0. In uncombined state is 0. Here is what? For zinc is 0 here. For zinc here is what? Is +2. Now class, if you look at we have from +3 to 0. From +3 to what? To 0. It means that there is decrease in what? In the oxidation number. Definitely reduction will occur here. Reduction will occur here. But if you look at this one now, from 0 to +2, that means what? Increase in what? In the oxidation number. Definitely oxidation occur here. Now, having indicate the reduction and oxidation reaction, what test are we going to do? We are going to balance what? We are going to balance the what? We are going to balance the what? The atom. You are going to balance the what? The atom. That's what you are going to do now. You are going to balance the what? The atom. Now, so if I balance the atom now, so how can I balance the atom? How can I balance the atom? So if I have to balance the atom, now, guy, firstly look at +3, 0. You can see that the atoms is, I have what? One atom of aluminum here. I have what? The coefficient of aluminum here is what? Is 1. If you check here too, is what? Is also 1. That means it's what? It is balanced atomically. But if you look at zinc 2 here, so the coefficient of zinc here is what? Is 1. This one too is what? Is 1. Atom has been balanced, right? Now let's move to what? To the charge. Now, so here is +3, here is what? Is 0. So in order to balance the charge, you will go and add number of electrons. You go and add electron to the side that had the highest charge. Now between +3 and 0, which one has the highest charge? +3. Definitely I am going to add 3 electrons to this side so that it can give me 0. It will be balanced like that. So the same thing applicable to this one. Here we have what? 0 here. We have +2 here. So +2 is what? Is greater than 0. So definitely I am adding what? I am adding 2 electrons to this side so that it can give me what? Is 0 here. Are you getting that? Now, so yeah, let's go now. So to balance this thing, to balance it, I'm going to have what? I'm going to put 3 electrons to this side so that what? So that I can have 0 here. It can be balanced. Now let's go. It will now be what? It will be Al3 plus how many electrons? Plus 3 electrons. Are you there? Plus 3 electrons to give me what? To give me Al. Now this one too, I have what? I have Zn to give me what? Zn2 plus 2 electron. Now I will have what? 3 minus 3 is 0. I have 0 here too. Are we there? Now here is already 0. So 2 minus 2 is 0. Now the next thing to do is what? Is to balance the what? The electron. Balance the what? Balance the electrons. So how can I balance the electron, class? Now very very simple. Now this is what I have. This is what I have. I have what? I have Al3 plus here plus 3 electron here to give me what? To give me Al. Abi, this is the first one. Second one, I have Zn to give me what? Zn2 plus 2A minus here. Now, how can I balance them at what? How can I balance the number of their electrons? Now, to balance the electrons number, now class, you are going to, now you can just call this one equation 1. Equation 1. You can call this one what? Equation 2. Now, so to balance the number of electrons in each of the equation, what I'm going to do now? If you look at, we have 3 electrons here. That means you multiply equation 1 by 2 and equation 2 by what? By 3. Now again, to balance the electron, that what? I'm going to multiply my equation 1 by what? By the number of electrons in equation 2. And to balance the number of electrons in equation 2, I'm going to multiply it by the number of electrons in equation 1. So that means if this is my equation 1, I will use what? 2 to multiply everything here. I have what? Al3 plus 3E minus to give me what? Al. Now here too, I'll be using what this number of electrons to multiply everything here. I have what 3 into bracket what Zn to give me what Zn2 plus 2e minus, right? Now when I use this one to open the bracket, you have what? You have 2al3 plus 6e minus to give me what? 2al. Are we there? Now, so the same thing applicable to this one too. I have what? 3zn to give me what? To give me 3zn2 plus 6e minus. You can see now, I have 6 electron here. I have 6 electron here. So they are what? They are equal. Definitely, they are going to cancel each other. They are what? They are going to cancel each other. And do you know what the next thing we are going to do? Now, the next thing to do is what? Now, I already have something like this. I have what? I have 2al3 plus, right? Now, no, I've cancelled the what? The number of electrons. So to give me what? To give me 2al, and another one I have 3 what? 3zn to give me what? To give me 3zn2 plus. Now, do you know what I'm going to do? We are going to add the product to product, reactant to reactant. Now, this my reactant. It will be 2al3 plus 3zn to give me what? 2al plus 3zn plus 3zn2 plus. Now, guys, let's check maybe what we have been doing is correct. Now, let's check maybe what I'm doing is correct. Now, this is a coefficient, Abi. We have 2. Now, 2 times number of charge. That's 2 times 3. I have plus 6. In the reactant side, I have plus 6. I have plus 6 in the other side. Do not forget that this one does not carry any charge. It's 0 already. It does not carry anything. It's 0. 0 times 3. That's what that is 0. That is the reactant side. I have what? I have plus 6 here. Now, in the product side, now don't forget that aluminum here too does not carry any charge. That's 0. 2 times 0 is 0. Plus, now 3 times plus 2 here, plus 6. Now 0 plus 6, that's plus 6. Definitely it's what it is balanced. It is balanced. So I have balanced it both what? Atomically, chargically, and what? And the electronically. Is that okay? So I have balanced it. The first thing is what? Indicates maybe the what? Indicates the reduction and oxidation reaction. That's the first one. Second one, balance the atom. 2, balance the charge. 3, balance the what? The electrons. Are we there? Now that's the what? The first example. Now let's check the second example. Example now, I was given, they give me equation like this. They give us iron 2 plus copper to give me Cu2 plus Fe. Now let's just say they give me Fe3 plus and they give me Fe2 plus. Now so what are the things we are going to do? Don't forget that we are going to what? Indicate oxidation and reduction. That's the first thing you are going to do. Now, so I have what? Fe3 plus to Fe2 plus. Now, guy, the first thing is what? Balance the atoms. How many atoms of what? Of iron they have here? 1 atom of iron, 1 atom of iron. Atom is balanced, but the charge is not balanced, right? Now I have plus 3 here. I have plus 2 here. Now what occurs here? Is this oxidation or reduction? It is reduction. It decreases from plus 3 to what? To plus 2. Definitely, it is what? It is reduction. It is reduction. Now from plus 3 to plus 2. Now here too we have copper to Cu2 plus, Abi. Now here is what? Is 0. Here is what? Here is what? Here is plus 2, right? Now from 0 to plus 2, what happened? Is oxidation. That means increase the oxidation number. So here is oxidation. Now having know that, what's the next thing to do? Is what? Now I will balance the charge. The charge is not balanced. I'm going to balance the charge. I have plus 3 here. I have plus 2 here. what are we going to do now? This guy has the highest charge. That means I'm going to add electron to that side, right? Now I have 3 here, I have plus 2 here, and I want to make I want to make the 2 equal. Definitely I'm going to add 1 electron to this side so that it can give me plus 2 here. Definitely I'll be having what? Fe3 plus E minus to give me Fe2 plus. Is that okay? Let's call it equation what? Equation 1. Now for the second one, I have a 0 here, I have plus 2 here. This side has the highest charge. I'm adding what? I'm adding the same number of electrons, so that if I add electron to this side, it give me 0 here. That means I will add 2 electrons to this side. So I have what? I have Cu to give me what? Cu2 plus 2E minus 2 minus 2 to give me 0. Now the next thing is what? Multiply the what? The equation 1 by the number of electrons in equation 2. That multiply everything by 2, and here multiply what? Multiply the second one by what? By 1. 1 is here. That's 1. Is that okay? So that the number of electrons can cancel. Now let's do. You give us 2Fe3 plus 2E minus to give me what? 2Fe2 plus. This one too will give me what? 1 times Cu. Cu to give me what? Cu2 plus 2E minus. I hope we are getting that. So the next thing to do is what? Is to add. Now you can see we have 2 electrons here. It will cancel each other. Is that okay? Now if it cancels each other, we are going to have something like this. Now we are going to have what? Something like this. Now this is what we have. We have what? We have, after we cancel electron, we have 2Fe3 plus to give us what? 2Fe2 plus. Now second one too, I have Cu to give you what? Cu2 plus. Now add the reactant to reactant, product to product. Now so that means I will add me what? 2Fe3 plus what? Plus Cu to give me what? 2Fe3 plus Cu2 plus. Now let's check maybe it's balanced. Now so what the coefficient that we have here? 2 times plus 3 plus 6. Are we there? Here we have 1 times 0. I get now. So 6 plus 0, I have 6 here. Now so in the other side too, 2 times plus 2, I have what? I have plus 4 here. Abi 2 times 2 plus 4. Here is what? I have 1 here. So 1 times plus 2 is what? Is plus 2. Now plus 4 plus 2 is what? Is plus 6. Balanced. I have balanced it. Is that okay now? So it's now balanced. It is balanced both what? Both atomically, chargically, and the electronically. So we are balanced the 3. Is that okay? Don't forget the step I gave you. The first thing is what? Is to indicate the redox reaction, either reduction or oxidation. That's the first one. Second one, balance them atomically. Balance the number of atoms. After balance the number of atom, what next is what? Balance the what? Balance the charge. After charge, balance the what? Balance the electron. So this has to what? This has to balance simple what? Simple ionic equation. Simple ionic equation. Hope you are getting that. Now, how can we balance this? Now let's check the next example. Next example. So they give us Cr3 plus 2Cr3 plus Al to give me what? To give me Cr plus Al3 plus. Now so they said we should balance it up. We should balance this simple ionic equation. So what the first thing we are going to do? The first thing is what indicates your reduction and oxidation reactions. The reduction and oxidation reaction. I have 2Cr3 plus and Cr, right? Now the first thing to do is what? Here I have 2. I have to put 2 here. Balance the number of atoms first. Is that okay now? Now 2 times plus 3, I have what? I have plus 6 here. Here I have a 0 here. Now so for me to make sure that both of them they are balanced, how many electrons am I going to add? I'm going to add 6 electrons here so that I can have 0. Hope you are getting that. Now I have what? I have 2 Cr3 plus 6 electron to give me 2Cr. Are we there? Now, so let's check the next one. I have what? I have Al to what? To Al3 what? 3 plus, right? Now here, 1 1 balanced atomically. Now here I have a 0. Here 1 times plus 3, I have what? Plus 3. But it is not balanced chargically. What are you going to do? I'm going to what? Add how many electrons here? I'm going to add 3 electrons to this side, because 3 minus 3 later giving is 0. We have what? We have 2Cr3 plus, right? Plus 6E minus to give what? 2Cr, right? And I have what? I have what? I have Al to give me what? Al3 plus 3E minus. Now, class, all my students, what are we going to do? I'm going to multiply equation 1 by the number of electrons in equation 2. I'm going to multiply this one by what? By 3. And I'm going to multiply this one by what? By 6. Is that okay now? So I have 3 times 2. I have 6Cr3 plus. Now, so 3 times 3, 6 times 6, 18E minus to give you what? Now, 3 times 2, 6Cr. Now, this 6 times Al, 6Al to give you what? 6 times this one, 6Al3 plus, right? Plus 6 times 3 plus 18E minus. Now, my students, what I'm going to do? Now, 18 electrons are cancel each other. That means I will add reactant to reactant. I will add product to what? To product. Now, that means I have what? 6Cr3 plus 6Al to give you what? 6Cr plus what? Plus 6Al3 plus. Now, let's check it. Maybe it is balanced or it is not balanced. Let's check it very well. Now, 6 times 3 is what? Is plus 18. Now, here, I have 6 here, but aluminum do not carry any charge. That means it is 0, right? Now, that means what? Now, 6 times 0 plus 0 in this side. Now, 18 plus 0, I have 18 here. Now, in this one too, yeah, don't forget that this is plus, right? Now, common here is 0. Now, 6 times 0, I have what? I have is 0. Plus, now, 6 times 3, I have 18. Now, 0 plus 18, 18. Balanced. So, this has to balance what? Has to balance simple what? Simple ionic equation. This has to balance what? Simple what? Simple ionic what? Ionic equation. Are we there? So, that's it. So, my name is what? Muideen Waliu, popularly known as what? Dr. Nefon. So, by next time or tomorrow, I'm going to drop what? I'm going to drop how to balance complex ionic equation. That is the one that contains radicals. So,